Hey there, mathletes. In this video today, we're going to look at different types of functions. So we're not going to have to solve anything. We just want to be able to identify the functions from their graph or their equation and know what their characteristics are. So when we see them, we can name them. So the most basic type we're going to look at is a linear function. So linear functions make straight lines. Now, all lines are straight. We just say straight lines out of habit. So the important thing is that there's no exponent other than 1 for x. So x to the first power is always just x. So we don't bother putting 1 there. It's like multiplying 1 times x is still just x. So linear functions do not contain x or y in the denominator. So that means y equals 1 over x. That is not a linear function. Okay? So the variables x and y also cannot be multiplied together. So if you had, say, x times y equals 6, even though x is still to the first power, this is not a linear function. So the most basic equation, the parent function, is y equals x, or f of x equals x, because then f of x means y. Here we have the standard form of the equation, a times x plus b times y equals c. And here we have the slope-intercept form, f of x equals m, which is the slope, times x plus b, which is y-intercept. And we say that they have a constant rate of change, or the slope is constant, it never changes. So we're just looking at the linear function. Again, f of x equals x, this is called the parent function. All other lines are just this function, either moved up, down, left, or right, and stretched up or flipped over. The parent function is actually a direct variation because it passes through the origin. From the table, you can see the rate of change is always 1. Every time y goes up by 1, that's the number in the numerator, and x goes up by 1, 1 over 1 is 1. This example is not a direct variation because it does not pass through the origin. So f of x still means y equals -1 half x plus 6. This means every time you plugged in an x number, you multiplied that number by -1 half, then added 6 to it. So if we check the table, every time the y number goes going down by 1, the x number is going up by 2. That's how we find the rate of change. Quadratic functions make kind of a U-shaped. Okay, this is called a parabola. It's not actually a letter U, it's a parabola. It can be fat, skinny, upside down, right side up. You must always have an exponent of 2 for x, so it's always going to be x squared. The most basic parent function is y equals x squared, or f of x equals x squared. This version is called the standard form, a times x squared plus b times x plus c. This version is called the vertex form. It tells you what the vertex, or the lowest or highest point of the graph is. In both cases, you see you have x squared, and over here you have x, and the squared is outside the parentheses. They're always going to go up and then down, or they're going to go down and then go back up again. So this shape, that's the parabola that we're talking about. Okay, so x squared means 0 squared is 0. 1 squared is 1. You'll notice on the table that they flip back on each other, right? You have 4, 1, 0, 1, 4. They repeat on either side of the vertex. So -2, 4, 6, it goes back to 4, back to -2, because they have a line of symmetry down the middle. You could fold it over, and it would be the same on either side. So if you know what 1/2 the graph looks like, you could find the other half. Exponential functions have a really sharp increase or decrease, and then a flattening out. So the exponential equation will have a number with x in the exponent. For example, y equals 3 raised to the x is an exponential graph. So either y equals a times b raised to the x, or a times b raised to the negative x. The negative exponent does not make it a negative number. Negative exponents are fractions, so this just makes it go down. So if x is positive, it's going to increase. If x is negative, it's going to decrease. So this one's called exponential growth because it's getting bigger. Because again, you have 2 raised to the x. So 2 to the 0 is 1. 2 to the 1 is 2. 2 squared is 4. 2 to the third power is 8, not 6. So again, it goes up very fast. This one starts up and then goes down very fast, because negative exponents of negative numbers make very large positive values. You're going to see it decreases and flattens out. This line that it doesn't cross is called an asymptote. So again, negative x doesn't give you negative values. It just gives you decreasing and then flattening out. Absolute value functions make a V-shape, literally a V-shape. They're two lines, so they have the same slope with opposite signs. If this is coming down at a -1, this is going up at +1. Remember, absolute value just means distance from 0. So if x is -1, the y number is going to be +1. This is called the vertex form, because again, the vertex is the point of the V. This is going to tell you where it's at, and if it's been stretched upside down or right side up, if it's skinny or fat. So you see it's a V shape, so both sides are linear. Just one line is coming down and one line is going up. So again, you'll see that the values turn back on themselves. 1, 0, then back to 1 again. -6, 4, -1, then back to -6 again. Okay? This one is upside down because it's multiplied by -1. So this is the parent function, which means this is the original graph. All other V-shaped absolute value functions are just this equation multiplied by something, something's added or subtracted to move it around. Since you added 6 inside, you'll see you moved it over to -6.